Today we're going to make some good old-fashioned artesian bread. It's a good, thick, substantial loaf of bread, which has a thick crust, and it's good to eat with a hearty meal. So it's good for the winter time, and good thing it's simple to make, and also we can learn some science with it. Well, that's a key thing. Learning some little science, all right? So what you need, it's spelled out here. You need 6+ cups of flour. Okay, so make sure you have some flour. I use all-purpose flour, and I'll explain a little bit more about that later. 2½ teaspoons of yeast. Okay, so yeast, that's one of those little packets. You can use a packet instead. You just buy a packet from the grocery store. 2 tablespoons of salt, if you're watching your salt, but with my wife likes salt, so add another half tablespoon, which salt gives it that flavor. Okay, so I go 2½ tablespoons of salt. Okay, yeah. Check with your doctor on that. And then 4 cups of warm water. All right, so that's pretty simple. And you also will need later on, of course, you need an oven. And the way this this recipe is, if you have a dish, you're going to put water in the oven. Okay, that's not required, but it will give that kind of a humidity to the bread, which gives it a nice moist consistency. If you have a stone, that's going to be good to put your bread upon. Okay. Again, you don't have to use a stone if you don't have one. It kind of helps retain that heat, though. Instead, you can just use an old-fashioned pan. Okay, we have this liner thing, but you can just use the pan, put a little bit of cooking oil on that. Okay, so so there's a little choice you can make there. All right, so back to the bread. All right, so first we're going to mix the ingredients. Okay, so I like to mix the dry ingredients first, so I like a nice big bowl. All right, so 6 cups of flour. So 1, 2, now notice I'm not measuring this real precisely. 3, 4, 5, and 6, because I'm going to be adding more flour later to get it to the right consistency. So that's less than I need. So that's how I'll come back to that. Add more flour later. All right. 2½ teaspoons of yeast. Again, you can use that little packet instead. Okay. 2, and then half again. 2½ teaspoons of the yeast, and then here's my salt here. 2½ tablespoons of salt. So there's 1, 2, and I'm running out of salt, but I got 2½ there. 2½ tablespoons of salt, and then I just kind of mix up the dry ingredients here. Mix it around a little bit, even before you start. Okay, before we activate it, before you activate those yeast. Now to do that, we're going to need warm water. Okay, so 4 cups of warm water. You want it about 100 degrees Fahrenheit. Okay. Again, you can go up or down from that. If you go down from that, it's just going to take a little longer to get the yeast activated. If you go above that a little bit, it'll be a little quicker, but if you go too high, then you will kill the enzymes in the yeast, and then your bread won't rise. You'll have unleavened bread, which will be just thick and dense. Okay, so good. Just the estimate on this is just put your wrist in there. Feel it be warm. So that's pretty good. You can get a thermometer out if you want to. That's getting a little hot now. There's 1, 2. Oops, it's too hot. Whoop. All right, I'll pull that down a little bit. 3. Now, of course, I washed my hands before I started doing this. So do a lot of that with COVID around, right? You know, wash your hands a lot. So it's got this mix, and you can see it's dissolving here. Of course, the water's doing that. Of course, I promised to learn do a little science here too, of course. But we're going to have time into the science when we're kneading, because kneading is a process which takes a little time. Okay, for me, and of course, we can only do one complex thing in our mind at a time. So as I'm teaching, I'm kind of only do one thing, can't multitask very well, unless they're two really simple things. And kneading, once you get going on it, it's kind of simple, so then I can do my, kind of tell you what's going on here with the bed breaking. All right, so you see it's really sticky here, okay? So at this point, you start adding flour, okay, until you get it to a nice, smooth, doughy consistency. Okay, so I add about a half a cup of flour at a time, and just stir it up. Okay, get a nice little workout here. That's a benefit, huh? All right. So just keep going with this. Hopefully you're doing this with me. All right. Okay, so let's get out the first little learning thing here as we go through this. All right, so first of all, what's the yeast for? Okay, well, of course, yeast is a living organism. Of course, when it's in this stage right here, and nice and cold, it's in a dormant stage. But the genus species name for this type of baker's yeast is Saccharomyces cerevisiae. Okay, so that's the genus species name for you biology nerds out there, like me, in my AP biology class. And you physical science students, you'll be there soon. All right, so where do you find it? You find it in nature, it's found in the soil, leaves, okay? Of course, they make it, they collect that and then they make it in these companies like Fleischmann's, they make it there, grow it. What actually it is, it's a unicellular, which means a single-celled eukaryotic fungus, all right? So eukaryotic, of course, you guys know that means it has membrane-bound organelles, okay? So it's a living organism, it's dormant in this stage, but once you add moisture to it and warmth and food, it becomes activated. So right now, it's starting to get active. Okay, so it's just waking up, so to speak. Okay, and when it wakes up, okay, it starts eating that food. Okay, okay, so the food it eats, of course, is the starch, which is in the dough. Now, sometimes you activate yeast with sugar, so you put it in like a little warm bowl of sugar, and that gets it going. So a lot of recipes ask for this, but in this case, I'm doing it right in the batter itself. Right? So, need warmth, moist, and then food source. Here's glucose, C6H12O6 for you science nerds out there. Okay, that's the sugar source. So the starch, which you find in the flour, okay, it has made up of these molecules here. Okay, it's going to be broken down into C2H5OH, which you guys maybe don't know, but that's alcohol. Okay, but luckily for us, when you're making bread, that alcohol will burn off, so you can't get drunk eating bread. The key thing here, we're going to make CO2. Carbon dioxide is a byproduct of this process, which is called fermentation. Okay, so that CO2 is what's going to give that bread the ability to rise up. All right, now see, it's still kind of gooey here. All right, so you're just going to keep adding flour to it. Get it. Oops, that's gets a little messy at times. Stick with it here. Okay, as you do this, you work it. You can't work it too much, really. A little bit more. My wife got this nice Santa placemat here. Motivating for Christmas season. All right, so you can see it's still going to be sticky, okay, but it's starting to come together. Okay. When it gets to about this point, what I like to do is kind of clean off my spoon here. I like to use a wooden spoon. You can use other types of plastic, whatever, it doesn't matter, but like that. All right, so let's look at the other ingredients. A little more science here. Okay, let's look. Flour, all right? So what exactly is flour? Of course, there's different types of flour. The kind here, of course, is wheat flour. Okay? So it's ground up wheat. Okay? Major component in it is, of course, carbohydrates, which is a food source. Okay? Starch, starchy, which starch is a polymer made up of sugar units. Okay? So that's what that yeast is going to eat. Okay? So now at this point, I'm going to stop teaching the science and just go here, get rid of that, put that back in there. And now Santa, you can go over there. I'm going to flour up the board here pretty generously because it's still pretty sticky. Then just put the dough out onto the board here. And now roll up your sleeves because now we get to do the kneading. All right. Okay, so this is the fun part. At this point the dough is still a little bit sticky. All right. But let's go back to that flour. What is it's besides the starch? It's got protein in it. It's called gluten protein. Okay, so you hear about gluten-free stuff. Well, wheat has a lot of gluten. That's the protein. Okay, so you can always remember gluten means kind of gluey. Okay, so it's what keeps things together. Okay, so like when you see those guys, the pizza guys, that are rolling it up like that. Okay, the reason it sticks together is because it's got a lot of gluten in that dough. All right. Now, there's different types of flour. If you're making a nice, delicate cake, you'll use I don't know, they call it cake flour. I never use it, but because I don't make cakes. But that's got about 3 or 4% gluten in it. All-purpose flour, which is what we're using, is 6 to 8%. And then bread flour is 12 to 14%. Now, I could make this with bread flour. If I did that, the consistency would be a little bit more dense, more kind of together. But this dough, if I want to kind of be airy inside and want to like these nice big air pockets, kind of sourdoughy, artesian-like. So all-purpose is what I like to use for this type of bread. All right. So of course, now what does that gluten do? Okay. Here we go. Okay, here we go. Gluten protein is a huge molecule. Okay, so you can talk about water. It's like H2O. Gluten C24, H27, N5O9. All right, so AP biology kids, you guys know about this. Protein, it's a polymer of an amino acid. Okay, an amino acid is a carbon with a carboxylic acid group off one end, an amino group off another end, just a hydrogen off one end. Remember, it's got an R group over here, which is different for those 20 different amino acids. All right, so it's a polymer. That means like a long chain of those amino acids. Okay, and this is mostly for my AP biology kids. You have a primary sequence, which is just the sequence of amino acids. Remember, it then folds up into a secondary, which is either alpha helix or beta pleated sheet. And then the tertiary is that interaction with the R groups, and that's going to give it its shape. So here's one, here's another, here's another. So in here, of course, there's billions of these little gluten proteins in there. Okay, and what they're doing, they're kind of attaching, becoming kind of gluey to each other. And the more you work this, okay, those glutens become more and more elastic. Okay, so you actually knead this for about 10 to 15 minutes. And as you do this, it starts to become a little bit sticky. So you can add more flour, or if it's gone off to the side, I just put the flour into the middle there like that. And I just keep kneading. Okay. And it's starting to feel kind of good now. It's nice and it's kind of warm. All right. Now, what else is going on here scientifically? So we got the gluey protein. Now that's going to be kind of forming pockets. Okay. So let's go back. Why warm water? Okay.